And now, dear students, after we talked about the cubic root, here we go with the fourth roots. In a similar way, the fourth roots of x are the numbers a such that a to the power 4 equals x. The positive fourth root is denoted by fourth root of x as you see here. So why did I say that the fourth roots of x are the numbers a? I said it in plural. Let's see why. Examples. The fourth roots of 16 are plus or minus 2. Since plus or minus 2 to the power 4 equals 16. So plus 2 to the power 4 is 16, minus 2 to the power 4 is 16 as well. So any positive real number has two fourth roots, a positive one and a negative one. And the positive one is denoted by fourth root of the number, which is 2. Similarly, for the fourth roots of 81, they are plus or minus 3. Since plus or minus 3 also to the power 4 is 81, and we write fourth root of 81, we mean the positive one, which is 3. Now the fourth root of minus 81 doesn't exist in R. Why? Because I cannot find a number that when multiplied by itself 4 times gives a negative number, because every time I multiply, if I multiply negative signs in pair, I will get a positive number. So I cannot write fourth root of minus 81. This is undefined in R, while cube root of minus 27, as you saw in the previous video, or minus 8 or whatever, is defined. So when the index outside is odd, then I can put a negative number under the radical, while when the index is even, as 4, as 2, as 6, as whatever, I cannot put a negative number under the radical. And now we are going to talk about examples, more examples, in order to make things clear. Here is to simplify fourth root of 16. All what we do is to change 16 as we did previously in the cubic roots. We change the numbers into powers of prime numbers, and we finally divide this power by this power to get 2 to the power 1. This power by this index, to get 2 to the power 1. Fourth root of 625 is fourth root of 5 to the power 4, which is 5. Fourth root of 0.0001, it is fourth root of 10 to the power minus 4, which is, when dividing minus 4 by 4, is 10 to the power minus 1. It's either 1 over 10 or 0.1. Fourth root of 32. Now 32 is decomposed into 2 to the power 5, which is 2 to the power 4 times 2 to the power 1. So I can simplify this by dividing 4 by 4 to get 2, while fourth root of 2 is kept here. Fourth root of 1296 is fourth root of 2 to the power 4 times 3 to the power 4. This will be 2 and this will be 3, and the final answer is 6. Here is 10 to the power 5. We have 5 zeros here, so it is fourth root of 10 to the power 4 times 10 as well. 10 is carried out by dividing 4 by 4, and 10 is kept inside the fourth root. And here are more to simplify. We have sixth root of 128, which is sixth root of 2 to the power 6 times 2. So I'm not just talking about fourth root, I'm talking about sixth root. 2 to the power 6 times 2, because 1 to 8 is 2 to the power 7. Dividing 6 by 6 we get 2, and the final answer is 2 and sixth root of 2 multiplied together. And finally, I have fifth root of 96, which is fifth root of 3 times 2 to the power 5 after decomposing 96. Now 2 to the power 5 will be carried out as 2, because dividing 5 by 5 will get 2 to the power 1, and 3 will be kept in the fifth root. So here were examples about fourth roots and fifth root and a sixth root, as you see here. So what is applied on cubic roots is applied on fourth roots in case of carrying out powers and so on, and in sixth roots and fifth roots as well.